Hello, hello. Hello. Hello guys, am I audible? Hi everybody, how are you all? My name is Ayush and we have been learning sequence and series from last two classes, I think, right? Yeah, sequence and recursive series is our topic for to a good level, and we have Hello, hello. Better now? This was the question we stopped at. Hello, hello. Better now? Yeah, this was the question we stopped at. Now it's coming. Now the voice is there. Actually, now everything is fixed up and let's start. So this is the question we stopped at. And if we look over here, we only realize that we can say that a plus d multiplied with r is equal to 4 and a plus 2d multiplied with r square is equal to 4. Both of them are equal to 4. If the question is saying that this is an AGP, then we have to definitely believe it, right? Because it's given. And if we are believing it, then we know the format. We know how an AGP looks like, right? When AP and GP both are merged together and there is a common ratio, there is common difference also. In that case, we get an AGP. So this is what I have. Now, if I look at this and if I fix this a little bit, I can say that A plus D whole square multiplied with R square should be equal to 16. Correct? Can I say that? If I square the first one and then I have this is equal to 16, correct? And then this is as it is, a plus 2d multiplied with r square should be equal to 4. So this is 16 divided by 4. The upper one, I squared the upper one and divided both of them. A plus 2d into r square will become equal to 4. This thing is given to me equal to r and I squared that side. Right now, why did I do it? Because I know a first of all. First of all, I know A. What is A? A is given to me as 3. First term is given to me as 3. Second term should be of an AGP should be A plus D into R. Getting my point? So that should be my second term. Now, if I want to find out D, I have to get rid of other terms. So I can cancel R square, R square. That's why I squared. Right now, 3 plus D whole square divided by 3 plus 2D is equal to 4. I just need to solve this and I'm done. Right? So if I solve this, 12 plus 8d should be equal to 9 plus d square plus 6d. Correct? Let's solve this out. So d square plus d square minus 2d minus 3 is equal to 0. Correct? So 1 minus 3, d is equal to, from here I get d is equal to 1 or d is equal to minus 1 or d is equal to 3. Right? Do you get my point? Correct? Either d should be equal to 3. We can put it also. You can solve this. You can solve this. This is nothing but d minus d plus sorry d square plus d minus 3d minus 3. This is how you solve, right? This is how you solve. You will take d common, then d plus 1 minus 3 common, then d plus 1. So d will be equal to either 3 or d will be equal to minus 1. If we believe it that d will be either equal to 3 or equal to minus 1. Now come back over here. Will be satisfied with our answer or not? Let's come back over here. If d is equal to 3, if d is equal to 3, a is also equal to 3. So d 3. Now minus 1 obviously we are not going to take, right? D minus 1, we can also take that also, but let's see that, let's say that d is equal to 3. I'm taking d is equal to 3. So 3 plus 3 into r should be equal to 4. Correct? If I'm taking d as 3. So that means r should be equal to 4 by 6. That means 2 by 3. If d is equal to 3, then r comes out to be 2 by 3. If my d is equal to minus 1, let's say I want to take minus 1 as my d. Suppose I want to take minus 1 as the common difference. So if d is equal to minus 1, in that case, what do I have? 3 minus 1 into r is equal to 4. That means r is equal to 2. Correct? So what am I having right now? I am having that this series 3, 4, 4. Let's check it. No, let's check it. 3, 4, 4. 32 by 9 is the next term. Okay, 32 by 9. So if I take my a as 3, my d is equal to 3, my r should be equal to 2 by 3. Let's say first term is 3 only, second term is 3 plus second term would be what? Should be what? According to our answer, a plus d multiplied with r is 2 by 3. So check 6 This is 6. 6 by 3, 2 2s are 4. This is my second term. Third term, what should be the third term? If our answer is correct, right? 3 plus 2 into d. Third term will be 3a plus 2d into r square. That means 2 into d would be 2 into d would be 6 multiplied with r square. That means 4 by 9. Are we correct? Yes, this is also equal to 4. And we can check fourth term would be 32 by 9. Even if we take a is equal to 3, d is equal to minus 1 and r will be equal to 2. In that case, r would come out to be equal to 2. Let's check according to this. Just check according to this. What would be your first term in this case? First term would be 3. Second term should be a plus d into r. That means 3 minus 1 multiplied with r, which is 2. Yes, this is coming out to be 4. If third term, let's check third term. A plus 2d, that means 3 plus 2 into minus 1, that means 3 minus 1. Sorry, 3 minus 2 multiplied with r square, that means 4. Yes, this is also correct. So both values of d are correct. D can be positive as well as negative, and we have to, it is already given in the question that we have to believe. Correct? So this was AGP in the last class. I hope you guys understood a little bit of AGP and the concepts related to it. I also told you the formula, direct formulas to be used. Now let's come upon to the next thing, which is summation part. Okay. After that, we'll go to AMGM. Let's understand the rule for sigma. Okay. Okay. Sigma notation. Sigma notation means this. Okay. Sigma notation just means this sign. This is the notation. Now, what all does it do? So, suppose I am writing k over here. Inside sigma, I'm writing k. And I'm saying that my k is equal to 1 from k equal to 10. This just simply means 1 plus 2 plus 3. So, I have to start from k equal to 1 and I have to stop at k equal to 10. Right? I have to stop at k equal to 10. That's it. This is what it means. This thing is called iterator. What is it iterating upon? It is iterating on k from k equal to 1 to k equal to 10. Right? So sigma over k, and iteration always happens on consecutive numbers like natural numbers 1, 2, 3, 4. From 1 to 10, I'm adding. This is what it means. This is expanded to this. Okay. Suppose if I'm writing sigma k square from k equal to 2 to k equal to 5. So this would simply mean 2 square plus 3 square plus 4 square plus 5 square. That's it. This is what it means. First of all, let's have an understanding about the term sigma. Okay, about the term sigma. Getting my point? हाँ बिल्कुल, लेजेंड गेमिंग यही काम करना और यही सब सीखना, बहुत बढ़िया. राइट? सिग्मा k equal to 1 to k equal to n. AK iteration is on k, so from k equal to 1 to k equal to n we have to add up, right? A1 plus A2 plus A3 till an we have to add, right? What is iterating? K is iterating. So 1 2 3 4 till n, from 1 to n. So this is what it means, right? If I do AR from r equal to 1 to n, this also means A1 plus A2 plus A3 plus A4 till an, right? What is the iterator over here? R is the iterator over here, right? We are iterating upon R from r equal to 1 to r equal to n. Now, if suppose something like this I'm writing, sigma over AK plus BK. Okay. Now, what would this mean? Sigma over AK plus BK, right? Iteration is happening on K only. Iterator is K. So, K is going to change. K is changing from 1 to N. To N. So, if I don't open this, what would this mean? This would mean A1 plus B1. First k is 1. Then k will become 2 and add it. So A2 plus B2. Then plus A3 plus B3. Like this till AN plus BN. So can I not write A1 plus A2 plus A3 plus A4 till AN plus B1 plus B2 plus B3 plus B4 till BN? I can do that, right? There is no problem. If I can do that, then this means that I can break sigma over addition and difference. Addition and difference. Right? Addition and subtraction, I can break my sigma over. If there is a constant over here, suppose if there is a constant, what would this mean? This would simply mean, this thing would simply mean that C A1 plus C A2 plus C A3, right? Because iteration is happening on K only. The thing which is changing is K only. So C is being constant and C is common in all, C is going to be common in all of them. So why don't I put C outside the sigma and just apply sigma over AK? So if a constant is there inside sigma notation, you can take it out just how you take a constant. Now the thing is that what would this mean? Sigma over 2 from, and I put R is equal to 1 to R is equal to 10. This has a meaning. It looks like it does not have a meaning, but this has the meaning. This means that 2 is being added up 10 times. Right? 2 is being added up 10 times, so this will nothing but 20. Right? 2 is being added up 10 times. That's it. So if there is a constant number, suppose if there is a constant number, sigma over 1 from R is equal to 1 to R is equal to n, this would simply mean equal to n, because 1 is being added up n times. This simply means that 1 is being added up n times. Understood? Are we? Right. Now let's move ahead and understand more about sigma. Okay, sigma of 1 from k equal to 1 to n would be equal to n, because this means 1 is being added up n times, and this means that, right? So this is about sigma notation. I hope you can understand this. Now suppose if there is multiplication or there is division, suppose if I'm writing sigma over ak multiplied with bk, okay, and k is being iterated from 1 to k equal to 10, let's say, okay, k from 1 to k equal to 10, I'm iterating this. Now what would this mean? Can I break sigma over multiplication? Yes or no? We'll see. No, what would this mean? This means a1 b1 plus a2 b2 plus a3 b3 plus a4 b4 till a10 b10. Correct? This is the meaning of it. This is the logical meaning of it, because sigma is over this entire expression. But what is the meaning of sigma ak multiplied with sigma bk? Where k is iterating from 1 to 10. K is iterating from 1 to 10. This is different, right? Don't you think so? This is different because this means a1 plus a2 plus a3 till a10 being multiplied with another sigma, which is a b1 plus b2 plus b3 till b10. And definitely you can say that these two are different things, that this is not same as this. So that means we cannot break sigma over multiplication and division, right? We can, obviously the same thing would happen with division also. Sigma over ak divided by bk will not be equal to sigma over ak divided by sigma over bk. Natural. Because what does this mean? This means a1 by b1 plus a2 by b2 plus a3 by b3. This means a1 plus a2 plus a3 till an divided by b1 plus b2 plus b3 till bn. Both are different things. Both are definitely different things. Don't you think so? Correct? Now, let's move a little bit more ahead. Let's understand general sigmas. Okay, this is what we should always know and remember, because this is going to help us solve a lot and lot of questions. This is going to be helping us in solving a lot of questions. This is what we need to remember. And by AP also, by the methods which we have learned for some summation of AP, some of the n terms of AP, by that also you'll be able to understand this. You can mark this. What does this mean? Sum of n natural numbers, k equal to 1 to k equal to n sigma over k. That means sum of n natural numbers starting from 1. Sum of this simply means sum of first n natural numbers. First n natural numbers. First n natural numbers. This is something which you need to understand and grasp, that I cannot say that sum of 2 plus 3 plus 4 plus 5 will be equal to 5 into 5 plus 1 by 6. No, I can only use this when the numbers, consecutive natural numbers, are starting from 1 itself. Sir, when will you an academy and test series come? Right now, I don't have the information for that, Arvata. Sir. Okay. Right? 1 plus 2 plus till n. Now, You see, sum of first n natural numbers can be given by n into n plus 1 by 2. Suppose if I'm doing 1 plus 2 plus 3, so 3 natural numbers, that means their sum will be equal to 3 multiplied with 3 plus 1 divided by 2. And I know that this is equal to 6. If I'm adding up first 10 natural numbers, let's say, so this will be nothing but 10 multiplied with 11 divided by 2. So it will be 55. You get my point? Right? So this we should know, that sum of first n natural numbers starting from 1 will be equal to n divided by n multiplied with n plus 1 divided by 2. And similarly, sum of squares of first n natural numbers, sum of squares of first n natural numbers will be defined as n multiplied with n plus 1 multiplied with 2n plus 1 divided by 6. Okay, this one you have to remember. And these are proven either by AP methods or by mathematical induction also. We can prove it right now. You don't need to worry about the proof. Just remember that this is the case. If you are adding up cubes, sum of the cubes of first n natural numbers will 1 cube plus 2 cube till n cube will be just square of this thing, n into n plus 1 by 2 whole square. Simple to remember. This is n into n plus 1 into 2n plus 1 divided by 6, and this is n into n plus 1 divided by 2 whole square. Now, the thing is, sir, how are the questions going to be? Let's see some questions. Now, before seeing some questions, I want to put your attention over one very important thing. What did we say about an AP? We said that any general term of an AP is A plus n minus 1 into D. We said this, correct? General term. Now, when I'm writing sigma Tn, okay, where n is from 1 equal to n equal to n, okay, that means n is starting from 1 and it is going till n. What would this mean? This would mean t1 plus t2 plus t3 plus t4 plus t5 till tn, isn't it? Won't this be? And what do we call it? Sum of all the terms is called as sum of n terms, sum of n terms of an AP. So naturally, if I'm applying sigma over Tn, that means nth term, general term, if I'm applying sigma over general term of an AP, it should be obvious and it should be natural that sum of n term should be obtained. Let's see, can we obtain it or not? Let's see. Okay, so now what is Tn? I am applying sigma over A plus n minus 1 into D. This is my Tn, this is the general term, where n is starting from 1 to n. Okay, now addition, so I can break the sigma, right? So sigma over A from 1 to n plus sigma over n minus 1 into D. That means sigma over nd from 1 to n minus sigma over D from 1 to n. Correct? I can do this. Right? Nd minus D, no? So I break the sigma because there is addition. Right? I have broken sigma only on addition. Now, what would be sigma over A? A is being added up n times. A is being added up n times. So that means this is nothing but an plus sigma over nd. D is a constant. Common difference, so it's a constant. I can put D outside. This will be sigma over n from 1 to n. Correct? And what will be this? Minus D is being added up n times. So this is nothing but dn. Okay, right? Now this is an plus D multiplied with what? Sigma over n, and n is iterating from 1 to n. That means 1 plus 2 plus 3 plus 4 plus 5 till n. That means sum of first n natural numbers. Correct? Sum of first n natural numbers, how do we write it? This is nothing but n multiplied with n plus 1 divided by 2. Correct? Minus dn. Can you see what I'm trying to do? Right? When you solve this, you get n divided by 2. N divided by 2 you can take common, right? Or you can take an LCM, okay? And it will come as 2a plus n minus 1 into d. When you are solving this, you are getting exactly the sum of n terms of an AP. But what do we learn over here? What do we learn over here? We learn that if you apply sigma over general term of any sequence which is recursive, which has a rule, Recursive sequence means if there is a rule, then there will be general term. You'll be able to write the general term. If you are able to write the general term, when you apply sigma over the general term formula and solve it, you'll get the formula for sum of n terms of that sequence. Amazing thing, isn't it? For example, for example, let's talk about this. Now this is a series. I don't know what is this AP, GP, because when I solve this, this is 3, this is 15, this is 35, and we keep on going like this. Nothing obtained, right? Is this an AP? Is this an GP? It will take time for me to think. What smarter thing would I do is, I want to know what is SN. Okay, general term if you want to write 1, 3, 5, right? This thing 1, 3, 5, 7, 9, 11. What is the general term over here? What is the general term over here? If you use AP also, no? Tn will be equal to 1 plus n minus 1 into 2. Common difference is 2. What is this? What is this? This is 2n minus 1. General term. So general term is 2n minus 1 over here. Wow, great thing. General term is 2n minus 1 for this part, these parts, right? Only these parts I'm talking about, the first parts, right? This and like this. Now about the second sequence, that means 3, 5, 7, 9. What will be the general term over here? Same thing, 2n minus 1. No, I don't think so. Tn will be, how will we calculate Tn? A plus n minus 1 into d, which is again, but A has changed and d is again 2 only. But this is what? This is 2n plus 1. So here the general term is 2n plus 1. So basically the thing is, now you should remember that if the odd numbers are starting from 1, the general term of that odd number sequence would be 2n minus 1. If they are starting from 3, then the general term for that odd number sequence would be 2n plus 1. Sorry, did we understand this? All right. If we have understood this, then what we can do over here, we can write Tn, the general term of this sequence. This is a sequence only. 1 into 3, comma 3 into 5, comma 5 into 7, comma 7 into 9. Correct? This is a sequence. Can we write the general term of this sequence? Yeah, we can write. This looks like 2n minus 1 multiplied with 2n plus 1. This is the general term of this sequence. What's the problem? You put n is equal to 1. What do you get? 1 into 3. You put n equal to 2. You get 3 into 5. You put n equal to 3. You get 5 into 7. Correct? N equal to 4 would give you 7 into 9. So this is the general term. This is Tn. Correct? Now what I'll do, I'll apply sigma over Tn. Before that, I'll try to solve Tn a little bit. 2n minus 1 into 2n plus 1 will be 4n square minus 1. Correct? Now I can apply sigma over Tn where n starts from 1 and goes till n. Why? Because I need to find sum of n terms. When I'm applying sigma, this Tn, sigma over Tn would give me Sn. That means sum of n terms. Correct? So this will be nothing but T1 plus T2 plus T3. T1 plus T2 plus T3 means 1, T3, T4 till Tn. That means 1 into 3 plus this same thing only I'll receive. So I'll apply sigma over 4n square minus 1. I'll break this sigma 4n square minus sigma over 1, right? From 1 to n, from 1 to n. Here 4 will come out, sigma over n square minus sigma over 1 would give me n only. 1 being added at up n times. And I know what is n square. Sigma over n square means n is starting from 1 and going till n. That means 1 square plus 2 square plus 3 square plus 4 square. Sum of squares of n natural numbers. That will be nothing but 4 multiplied with n into n plus 1 into 2n plus 1 divided by 6, correct, minus n. This will be my answer. The thing is that if we are aiming towards finding the sum of n terms for recursive, write its general term and apply sigma over it. You just need to remember sigma, sigma n square, sigma n cube. More than that, it won't come. Okay, more than that, these are all good questions and which have appeared or similar questions have appeared in PRMO. On the basis of that only you are doing. Okay, Satya? All right, all important questions, I'll think about it. All right. So what did we have? 4 multiplied with n, and if we solve it, this thing, if we solve this thing, we are getting this particular formula, right? When you solve this, no, you'll get this formula. This will be your final answer. And now suppose if you want to find sum of 100 terms of this, so you put 100 instead of n in this formula. If you suppose they ask you to find the sum of 100 terms of this particular recursive sequence, then you just need to find the formula for sum of n terms and then put n as 100 in this formula. I hope you get my point. Okay, now let's see this. Sum of n terms of squares of odd numbers. Sum of squares of n odd numbers. What will be the formula for that? Let's try and understand. So 1 square plus 3 square, general term, Tn if I want to write. How will I write Tn? Odd numbers are starting from 1. So that means 2n minus 1 whole square is my general term, right? So Tn is nothing but 4n square plus 1 minus 4n. Correct? Now I'll apply sigma over Tn, where n starts from 1 and goes till n. This means T1 plus T2 plus T3 plus T4 plus T5. Right? That means 1 square plus 2 square, 1 square plus 3 square plus 5 square plus 7 square and so on till n. Correct? So sigma would come on this 4 sigma 4n square plus sigma over 1 minus sigma over 4n. This will become what? 4 into n plus 1 into 2n plus 1 divided by 6. This will become n. This will become 4 into n plus 1 divided by 2. We'll solve this to get the final answer. Correct? So 2 2's, this will become n into n plus 1 into 2n plus 1 divided by 3 plus plus n minus 2n into n plus 1. Okay, so I think n into n plus 1 you can take common. N into n plus 1 will come out common for you. And then here inside you'll have 2n plus 1 divided by 3 plus 1 minus 2. This will be your final answer. Sum, we have to find the sum up to 10 terms. So this is our sum of n terms. This is our sigma over Tm would give us Sn, right? Sum of n terms. Here only if we need to find S100, sorry, sum of 10 terms. So we need to find S10. S10 will be what? 10 multiplied with n means 10. 10 plus 1, that means 11. Multiplied with 2 into 10 plus 1, that means 21 by 3, that means 7. Right? 2 into 10, 20 plus 1, 21 by 3, 7 plus 1, 8, minus 2, 6. So this is our answer. That's it. 66, 660 will be our answer. Sum of 10 terms will be nothing but 660. This is how you need to solve a sum of sequence, just like that. Are we clear to this? Uh, just check once. Okay, shall we move ahead? Okay, now let me give you a question from 2018 PRMO. Okay, from here only, over here only. Let's try this. Let's see if we are able to do this or not. Okay, the question is, I'll write from PRMO 2013. Okay. Okay, what does the question say? Question says, question is let m be the smallest odd positive integer. Odd positive integer. Let m be the smallest odd positive integer for which this thing 1 plus 2 plus 3 till m is a square of an integer. Is a square of an integer. Okay, and let n be, and I'm writing here, and let n be smallest odd, I've written, no, n is smallest even positive integer. N be the smallest even positive integer. Okay, even positive integer for which 1 plus 2 plus 3 till n, till n is a square of an integer, is a square of an integer. Is a square of an integer. Then you tell me uh, the value of m plus n. Come on, try this out. The question is saying let m be the smallest odd positive integer for which 1 plus 2 plus 3 till m is a square of an integer, and n is the smallest even positive integer for which 1 plus 2 plus 3 till n is a square of n integer. Is a square of an integer. Is a square of n integer. N integer. Okay. So how will we solve this question? See, it's just the language. Most of the times PRMO questions you'll see, it's just the language which will bother you. You'll always know the concept and something to do about with the question. Something to do with the question. Let's see. Now, what information do we have? What do we know already over here? We know that something like this 1 plus 2 plus 3 till m is square of this sum is square of some integer. Let's say k is that integer. Okay, let's say k is that integer and m is the smallest odd integer, smallest odd positive integer. That's what they said, no? M is the smallest odd positive integer for which 1 plus 2 plus 3 till m is a square of an integer. What is this 1 plus 2 plus 3 till m? This will be sum of m natural numbers, sum of first m natural numbers. So that can be written as m into m plus 1 divided by 2. Can't we write that? We can write it like this. This will be m into m plus 1 divided by 2. And this thing should be square of an integer, not odd or even. Square of an integer. That's why question is written very carefully. This is just a square of an integer. So we'll check. Let's say m is equal to 1. If we put m is equal to 1, what does it give us? 1 into 1 plus 1, that means 2 divided by 2 is equal to 1. And 1 is the square of an integer. 1 is the square of an integer. Suppose if we took m as 2, then it will be 2 into 3 by 2, that means 3. Correct? Which is not the square of an integer, but 1 is. So that means m is equal to 1. That means what do we find? That m should be equal to 1. Why? Because m is the smallest positive odd integer. This is odd, and the sum of one natural number is giving us the square of an integer, right? Sum of 1, m is, so we are summing up only one natural number. Sum of 1 will be 1 only, right? Sum of 1 will be 1 only. I'm saying 1 plus 2 plus 3 till m can be written as m into m plus 1 divided by 2. Correct? Now the question is telling you that sum of m is the smallest odd positive integer for which this sum is becomes the square of an integer. So what is the smallest odd positive integer? 1. Correct? Smallest odd positive integer is 1. So sum of one odd number will be 1 only. Correct? And 1 is the square of an integer, which is also correct. 1 is the square of 1. 3 is not the square of an integer. 1 is the square of an integer. That means m is equal to 1. From here, what do we find out? That m definitely is equal to 1. Now, what is about n? Let n be the smallest even positive integer for which this sum 1 plus 2 plus 3 till n is the square of an integer. Okay, let's check. So, we know 1 plus 2 plus 3 till n. What is n over here? N is smallest. No, n. What information have they given about m? N. N is the smallest even positive integer. Smallest even positive integer. Okay, and this sum should be equal to square of an integer. This sum should be equal to square of an integer where k is an integer. Okay, this is what the question is telling us. So we know that sum of n natural numbers will be equal to n into n plus 1 divided by 2. Now we want this thing to be square of an integer. We want this thing to be square of an integer. Correct? We'll check. We'll put n is equal to 1. What do we get? 1 into 2 by 2, that means 1. When we put n is 1 is not the square of an, is 1 the square? Sorry. Can we put n is equal to 1? We cannot put n equal to 1, no, because they have said that n is smallest even positive integer. So we'll have to start with 2. So we'll put n is equal to 2. What is n equal to 2 going to give us? 2 into 2 plus 1, that means 3 divided by 2, which is equal to 3. And 3 is not the square of an integer. Then next even number we'll try. 4. 4 will give us 4 into 5 divided by 2, which will be 10. And 10 is not the square of an integer. N equal to 6 we'll check. So 6 into 7 divided by 2, which is 21. And 21 is also not the square of an integer. We'll check n is equal to 8. Now 8 into 10 divide 8 into 9. Sorry. 8 into 8 plus 1. Na? 8 into 9 divided by 2 is equal to 36, which is square of 6. That means when n is equal to 8, 8 is that smallest odd integer. 8 is that smallest, 8 is that smallest even integer. So sum of first 8 numbers will become the square of an integer. So n will be equal to 8. What do we get? N equal to 8. And our answer will be m plus 1. N, that means equal to 9. This was the answer. How easy was this? It's just the interpretation that we have to take care of. What do you think? Correct? All right. Let's do a couple of more. Are we clear? Yes, very good. Now, something like this. Don't worry about the PY, where are the questions from, but this question can be also asked in your Olympiads, PRMO, IOQM, and also. And this was asked recently, and not recently, but in 2020 in JEE Mains. Now, but we have to understand what is it saying. Here we need to understand what is the sigma saying. Okay, sigma is over 1 plus 2 plus 3 till k. So naturally one thing which comes in our minds are this means that sigma over this means this is nothing but sum of k natural numbers, k into k plus 1 divided by 2. Now we'll put k equal to 20 and this will become 20 into 21 divided by 2 and answer will be 210. How many classes more of this lesson? I think 2 more. Okay, 2 more. Okay, sigma, we have started doing PYQs now, so we have reached a good level. Now 2 more and we'll be done. Okay, then you'll be able to attempt all the questions and solve them. Right, this comes in our mind. But here the understanding of sigma will help us understand that this is not what we are supposed to do. What is the iterator? Iterator is k. Correct? Iterator is k. Right? Iterator is k. And summing up, we are doing sum up till k. So this would mean sigma over this would mean then first k is 1. So we'll just add it till 1. Then k will be 2. So we'll add 2 numbers, 1 plus 2. Then k will be equal to 3. Then we'll add 3 numbers, 1 plus 2 plus 3. Then k will be equal to 4. So we'll add 4 natural numbers. And we'll keep doing this till 20. We'll keep doing this. Why? Because k is till 20. 9. 1 plus 3 plus 6 plus, right, that thing only. 1 plus 3 plus 6 plus 10 plus 14 plus 19. Very good, very good. Right. Correct. 2, 4. You can also solve it with, if you are thinking, you can also solve it with method of difference. But you see how helpful will summation be over here. Summation will be very helpful over here. So Shreyansh has written something. He's written 1 plus 3 plus 6 plus 10 plus 14 plus 19, right? So here there is one more approach which students learn, method of difference, which we can also use over here. So this is same thing only. This is what it is asking, but the question, the asking of question is way different than what we can think. But you see, if we can understand this, we can solve that also. Suppose Shans, that thing came. What does the question say? Question is saying this only. This is what the question is saying, Mithil. Mithil, this sum we need to find, right? First 1 plus 3 plus 6 plus 4 into 5 by 2, that means 10, right? 14, then 19. This is what we need to find till this sum, 20 into 21 by 2, till 210, 1540. Shreyans is saying. But can we do something else? See, inside sigma itself, there is a summation series. Inside sigma itself, there is a summation series. So this summation series, so we know, na? 1 plus 2 plus 3 till k. That means sum of k consecutive natural numbers starting from 1. Okay, so this means k into k plus 1 divided by 2. And now we'll apply sigma over here. K equal to 1 to k equal to 20. Problem solved. So 1 by 2, because it's a constant, will come out. Inside what we'll have, k square plus k from 1 to 20. So 1 by 2 stays outside. Sigma over k square from 1 to 20 plus sigma over k from 1 to 20. This will become 1 by 2, right? Sigma over k means sum of squares of first 20 natural numbers. That means n into, sorry, 20 into n plus 1. That means 20 into 21 into 2n plus 1. That means 2 into 20 plus 1. That means 41 divided by 6 plus sum of first 20 natural numbers. That means 20 into 21 divided by 2. And this will be our answer. This thing will be our answer. Got my point? After this, which lesson? After this, PNC ma'am is teaching right now. Geometry also is going on. Let's see. Let's see. Let's get over with this first. Whatever. Okay. We'll decide. Calculate this. Please calculate this. Two threes, to 10, 3, 7, 17 to 41 plus 210. 210 multiplied with 1 by 2. This thing. So 2870 plus 210 divided by 2. I think 313080 divided by 2. Yes, your answer was correct. 1540. 1540 was correct, chance. Very good. Right? This would be the answer. 1540. Okay. This can also be asked. Now let's do one more PYQ. Let's do. Okay. Then we'll do the other type of questions. Let's do one more PYQ. Then I'll teach you if more sigmas do come. Okay. Okay. Let's do this. Question is simple. This question was asked in 2013. Okay. Question is very simple. It is asking you what is the maximum possible value of k today. Because of crunch of time, I couldn't get this typed. Next time I'll get this typed so that we can save the time. For which 2013 can be written as sum of k consecutive positive integers. Can be written as sum of k consecutive positive integers. Sum of k consecutive positive integers. Good question. You have to tell me what is the maximum possible value of k for which 2013. Sir, have you taught double sigma? No, I didn't teach till now. I'll teach you double sigma also. Double sigma is going to come. Don't worry. Okay. Before that, try to solve this. What is the maximum possible value of k for which 2013 can be written as sum of k consecutive positive integers? Read the question very carefully. This is the most, sir, I learn all the concept, but I cannot be able to solve the questions. Beta, maths is like that. Okay, don't give up. If you give up on solving the question, with everybody the same thing happens. Learn the concept, but difficult to solve the questions. See the solution once. From the next question, again fight very well. If you stop fighting and keep looking for the solution and give up, math is not your cup of tea then. But it's not that difficult also. It's not that hot of a tea, but okay, keep trying, keep fighting, be a good fighter, and so on. Quadratica. I don't know. What is the maximum possible value of k for which 2013 can be written as sum of k consecutive positive integers? Very, very carefully you'll have to read this question and understand this question. Okay, because you can do one mistake. You know what's the most important thing to read about in this question? This thing. K consecutive positive integers. It's not anywhere intending or implying that we are talking about first k natural numbers. The formula which we have learned, no, n into n plus 1 divided by 2 is for the first n natural numbers starting from 1. That formula is not for any consecutive sequence of natural numbers. It's not for that. Yeah. So how do we solve it? What is the maximum possible value of k for which 2013 can be written as sum of k consecutive positive integers? By consecutive positive integers, let's say something like this is happening. Okay, a plus 1, a plus 2, a plus 3. Correct? This is what's happening. Sir, 1 minute. Acha, theek hai. One. All right, I'll give you a minute. Come on, solve it. Maximum value we have to look at. Can you see that? Maximum. Shall I start? Okay, let me explain. Let me keep explaining. You do. All right. A plus 3 like that like this sequence is going. Right? Like this first number, second number plus third number, fourth number, like this. Like this. We started from A and consecutive numbers, so difference is going to be 1. Correct? Consecutive numbers, so difference is going to be 1. Do you believe that? Okay, and what will be the any general term? We are talking about k positive numbers, k positive consecutive numbers. Correct? K positive consecutive natural numbers. So here for second term is a plus 1, third is a plus 2, fourth is a plus 3. So kth term will be a plus k minus 1. Correct? It will be a plus k minus 1. Sorry. Formula, that sigma formula is not going to work, but we know n terms. This is an AP only. We know sum of n terms of an AP, right? What is the formula for sum of n terms of an AP? Right? How many terms are we adding? K terms. Sir, k divided by 2. K terms we are adding, no? K terms we are adding. What is the question? I'll make you read this again. What is the maximum value of k for which 2013 can be written as sum of k consecutive positive natural numbers? So sum of k consecutive positive natural numbers, it's not starting from 1, Shreyansh. It's not starting from 1. Otherwise, I would have used k into k plus 1 divided by 2. Who said it is starting from 1? That's the question. That's the beauty of the question. Nowhere it is saying that we are not talking about sum of first k consecutive natural numbers. We are talking about sum of k consecutive positive integers. Okay, so we have just this formula, k by 2 into first term, that means 2a plus n minus 1d. Instead of n minus n, we are talking about k terms, so k minus 1 into d, which is 1 only. D is 1 only. This should be equal to 2030. And in this, what should be the maximum value of k? That's what we need to find. In this, what should be the maximum value of k? Okay, ji. Okay. Now think. What do you think? Now tell me. Okay, let's sort this a little bit. What else we can do? Right? Let's sort this a little bit. We know one thing. Okay, we know one thing, that a is positive. Yes or no? Because k consecutive positive integers. So a is positive. Right? Here in the bracket somewhere we can write a is positive. Not even 0. Positive means positive. 0 is neither positive nor negative. A is positive. Okay. So k divided by 2, this side something like this. What we can do is 4026. This will become, so 2a plus k minus 1, okay ji, is equal to 4026. Okay, and now so our a will be equal to 4026. Acha, 4026 divided by k also, here divided by k. Okay, it will be 4026 divided by k plus 1 minus k divided by 2. Here 2 will also come. This is what we are getting. And we only have one piece of information, that this macha a is positive. This boy a is positive for sure. That's what we know. Now we'll check at bhai, if this value is decreasing, then only we'll be able to find. Then only we'll be able to find our answer. Otherwise, we cannot find. This particular value should be decreasing. We know k is a natural number, right? So if we put k is equal to 1, what are we getting? On k equal to 1, calculate. 4026 plus 1, 4027 minus 1, 4026 divided by 2, that means 2013. Okay, 2013. What is the asked in the question again? What is asked in the question again? Maximum possible value of k. So that 2013 can be written as the sum of k consecutive positive integers. But till now we just reached k equal to 1. Now we'll check at k equal to 2. Check at k equal to 2. Value should be decreasing, and definitely this value is decreasing. K equal to 2, that means 2013 plus 1, 2014 minus 2, 2012 divided by 2, right? 2012 divided by 2. Getting my point? Value is decreasing, yes or no? You tell me, value is decreasing, yes or no? By one way is that you could factorize the right part. Yeah, some student this also could be factorized. Sir, I start preparing. You can, beta. You start. If you keep thinking about how to complete the syllabus, then it will never get completed. Right? The key to avoid procrastination is start today. Start now. That's it. At k equal to 2, what are we getting? 1006. That means values are decreasing now. So you tell me what can be the maximum value of k. You try 3, 4, 5, 6, everything now. At k equal to 2, this is 2013 plus 1, and at k equal to 3, this would be 1342 minus 3 plus 1 divided by 2, that means 670. You'll have to check like that. Okay, but we cannot check like this. Yeah. Wait. We'll have to do something else also. We'll have to check the factors of 4026. We'll have to check the factors of 4026. That also we'll have to take in account. Otherwise, we'll keep doing this k equal to 1, k equal to 2. You're getting my point, right? You'll have to check the factors of 4026. Because this k is an integer. So factors of 4026 you'll have to check. Okay. 4026 factors you'll have to check. Check the factors, guys. This is going from okay, 2 also. Right. So 2 and 4, 2013 will be 1. Then 3, from 3 it will go at 1342. 3 6 18 213731. Okay, and this will go from 3 again, 3 to 1 1. No, 3, it won't go from 3. It will go at 11. 6 or 66, yeah, 11, 66, and then 1, and then 61. 61 is prime, right? 61 into 1. So yeah, we can check with 61. The highest one is 61. Check at 61, no? Directly check at k equal to 61. We can check at 6, 33, 22, and 61. Right? So k equal to 61. Let's check at k equal to 61. What is the value that we are getting? 4026 divided by 61 plus 1 minus 61 divided by 2. If this is the least, we can check, right? Because whatever k is, it has to be a factor of 4026. Whatever k is, k has to be a factor of 4026. So we just need to check the factors of 4026. Are you getting my point? Yes or no? So this will come as 66 minus 61 plus 1, 3. This is coming out as 3. Now check at 60. There is no other factor, right? There is no other bigger factor. So 61 would be our answer. Even if we check at 62, no, it's not going. There will be a negative value. You see, values are decreasing. So at k equal to 61, we are getting 3. At k equal to 61, we are getting this value 3. That means our answer is nothing but k equal to 61. This is our answer. Because k has to be what k needs to be. K needs to be the maximum possible value of for which 2013 can be written as sum of k consecutive positive integers. So k should be 3 only. K is equal to 61. That means 2013 can be written as the sum of 61 consecutive positive integers. Yeah, Siri, tell me. Tell me quickly about this. About this, do we have a question? Anji? Come on, Siri. Okay. Thank you, Zoltar. So you see, PRMO questions, if we have understood the concept and if we are reading and interpreting the question very correctly, then we'll be able to solve PRMO questions very easily. Yeah, tell me, Siri, whatever it is. Okay. A couple of more. All right. One question I'll give you. You can solve it. Right? You can solve it. This question is from. Uh, this question is from PRMO 2018. Oh, sorry, 15 or 18. Pata nahi. Year is not written. Okay. You have to find the. Okay, this is the series 1 3 3 3 5 5 5 5 3 4. Okay. This is the series. You have to find this series 2016th term. Find 2016th term of this series. This is PRMO 2015. Give it a try. Come on, guys. 1 3 3 3 1, then 3 times 3, 5 times 5, 7 times 7. Okay. Come on. What will be the 2016th term of this sequence? I'll give you a minute for this. Easy this is. 2016th term of this sequence. All right, we'll start with this, sir. Show that n square plus 20 by n is divisible by 48. N square plus 20 into n is divisible by 48. Sound is not clear. Better now? The sound is clear now? Is the sound okay, guys? Hello, hello. Hello. Yeah. Right. So sorry, I think there was a lag or some interruption. I hope it's better now. We were. Can you explain the above question? So series saying n square plus 20 into n is divisible by 48. There must be some information about n also, bache. There must be some information about n, otherwise it's not true. It's not always. Okay. Now, if it is divisible by 48, then you can do something about it. I think your question is half complete. Yeah, the question was to find its 216th term. I hope you guys tried solving this. Now, what do we know already? What do we know already? We know this, right? Sum of one odd natural number is equal to 1 square. Sum of two odd natural numbers is equal to 2 square. Sum of three odd natural numbers is equal to 3 square, right? Sum of four odd natural numbers is equal to 4 square, right? We know this, correct? We know this information already. Sum of one natural number will be equal to 1 square, like this. Okay, but how do we use this, sir? We don't need to find the sum, we need to find 2016th term. But what is the pattern? See, one term, so 1 square. Now, second natural number, till second odd natural number, we have 4 square, like 2 square, right? 4 terms, right? Till here we have one term. till here we have 2 square terms. Till here how many terms we have? 5 plus 3 plus 1. That means 3 square terms, right? Till here how many terms do we have? 4 square terms. And these are 4 odd numbers till now. Till here we have 16 terms. You can see that till here we have 16 terms, and we have 4 natural number 4 odd numbers till now. Till here 1 term, till here 2 square terms, till here 9 terms, so 3 square, and till here 4 square, so 16 terms. Now we need to find the 2016th term. Okay, so that means some square number near 2016. I know 45 square is equal to 2025. If we calculate 46, no, 44 square, let's calculate 44 ka square. So 44 square would be 1936. Okay, 44 square will be 1936. Okay, so 44 square is 1936 and 45 square is 2025. We need to find 2016th term. What does this mean? That means till till 44th natural number, till 44th odd number, we will have 1936 terms over here. Till 40, till second odd number we have 4 terms. Till third odd number we have 9 terms. Till fourth odd number we have 16 terms, which is 4 square. So till 1936, till 44th odd natural number, we will have 1936 terms. We need to reach at 2016. Okay, so 2016 minus 1936, if we do, how much do we get? 2016 minus 1936, if we do, okay, 80 terms we have, right? We didn't even have to, yeah, 80 terms, right? 80 terms to go. That means we have to go 80 terms. That means, right, till 1936th term, we will have, till 1936th term, we will have 44th odd number. Which is 44th odd number? 88 is our 44th odd number, right? Till 1936th term, 1936th term, we will have 44th odd number, which is 88. 44th odd number will be 88, no? Correct? 44th odd number, second odd number is 3, third odd number is 5. Right? 3 2s are 6 minus 1. 44 odd number will be 88. 44th odd natural number will be 87. 87. Right? 44th odd natural number will be 87 only, no? So now we can calculate. And what will be the first odd number which is after 44? It will be 89. Correct? So 1937th term, the 1937th term will be 1981 again. Right? So we have so the 80 terms, then after 80 terms, we'll have to subtract 45 more. So 45 times 45 will appear. So our answer will be 89, right? Till 89th term, this will keep going on. Till 89th terms, this will keep going on. So that means 2016th term, 2000 till 2015th term, till 2015th term we will have 89, and then 2016th term will be our 91. This will be our answer. Okay, I hope you have understood this. Very good question. Logical, no sequence and series. We just needed a simple information how to go, how to approach the question. Right? Understood my point, right? Till 44th odd natural number, which is 88, we'll keep having 1986, 1936. then 89 will come for 45 times, and then we'll have 91th term. Till 89th term we'll have 40 like 44th odd number only, till 1936th term. Then 1936 plus 45 we will have 89, and then for 2016 we will have 91. This is how we'll have to calculate this. Now some more things, a few more type of questions I'll show you. Just give me a minute. One more type of series which I needed to show you, which is just a minute. Array. The one which Shreyansh was talking just now. I want to pay your attention towards that also. Okay. This type of sequence, right? This is also something which you should know how to solve. Find the nth term of the following series, right? Suppose if we have something like this 5 plus the, if you are given with sum and you have to find the nth term of this series, how will you do that? Now whatever is given to you is sum of n terms, right? 5 plus 7 plus 13 plus 31 plus 85, like this. Now directly if we see, this is neither forming an AP nor forming a GP, but if we look at the difference, 7 plus 5 is 2, then 13 minus 7 is 6, then 31 minus 13 is 18, correct? And this is 54. So 2, 6, 18, 54 is forming a GP for me, but directly I'm not able to see, in this I'm not able to see that if there is an AP or GP. But suppose difference of the terms is forming an AP, this is called telescoping. This is what we call telescoping. Now difference of these terms is forming an AP form, is forming a geometric progression for me. 2, 6, 18, 54 is a geometric progression with common ratio of 3, right? So in this case what can I do? In this case what can I do? Now this is going to be till some term Tn, right? Tn, this is going to be till some Tnth term, right? Nth term. What am I going to do is I'll write the same thing again. Sn only I'll write the same thing again, but I'll shift the terms. I'll shift the terms. 5 plus 7. The method to do this is just shift the terms like this. 5 plus 7 plus 13 plus 31, right? Till second last term and last term. Last term will be Tn, second last term will be Tn minus 1, but obvious. Why did I do this? Because when I'm subtracting this, when I'm subtracting over here, I can see that Sn minus Sn will become 0. Subtract this side. So 5 minus 0, 5, plus 7 minus 5, 2, 13 minus 7, 6, 31 minus 13, 18, right? 85 minus 31, 54, right? Tn minus Tn minus 1, correct? And because we are subtracting, here we'll have minus with Tn, because we are subtracting these two. Now see how magic will happen. This thing I know is a sequence which I know to solve. Geometric progression. Simple, right? This minus Tn I'm going to bring over the left side. And this side I'm going to have 5 plus 2 plus 6 plus 18 plus 54. Till how many terms are these? How many terms are these? N minus 1 terms, right? Because we have shifted the series. So these are N minus 1 terms. because we have shifted the series. No, till here we had n terms. These are n minus 1 terms. Getting my point? We have shifted the series, so this sum is for n minus 1 terms. Got my point? Till n minus 1 terms. Now Tn will be equal to what? 5 plus. This is sum of n minus 1 terms. What is the sum of n minus 1 terms? For a geometric progression, a into 1 minus r to the power n divided by 1 minus r. That means 2 into 1 minus a is 2, 1 minus r is 3, 3 to the power of n minus 1 divided by 1 minus 3. That means 1. Or we can do ulta also, because here negative will come. So to get rid of negative, we'll write 3 to the power n minus 1 minus 1 divided by 3 minus 1, which is 2. That's it. So 5 plus 3 to the power n minus 1 minus 1, that means 4 plus 3 to the power n minus 1 will be its Tn, nth term, any term. Correct? See, first term, if you see T1, what will be T1? 4 plus 3 to the power 1 minus 1. That means 4 plus 3 to the power 0. That means 4 plus 1. So 5. What will be second term? T2. 4 plus 3 to the power 2 minus 1. That means 4 plus 3, which is 7. Third term, T3. 4 plus 3 to the power 3 minus 1. That means 4 plus 3 square. 9 plus 4, 13. Got my point? So this is how you can calculate the general term of a sequence where directly you are not able to observe anything, but your differences are telling you something. The difference between the terms is telling you something. Okay, let's see this. Okay. Yeah, this question was asked. This is one question. Okay, let's see this. If we observe that directly we are not able to observe anything, 11 minus 5 is 6. 11 minus 19 is 8. This is 10. This is definitely 12. Okay, AP is forming. What we'll do, we'll apply method of difference. What we'll write, we know that sum of n terms for this thing is given to me as this. Okay, for n terms till some term Tn. Right? This is being added. Now I'll shift it because difference is working, so I'll shift it. 5 plus below this will come Tn minus 1 and here will be Tn. Okay, now I'll subtract both the sides. So 0 will be equal to 5 plus 11 minus 5, which is 6, plus 8 plus 10 plus 12, and likewise till Tn minus Tn minus 1. Minus Tn. Minus because we are subtracting. Minus is coming because we are subtracting. Main topics are these only, beta. Recursive series is one of the main topics. PNC is one of the main topics. Geometry is very important in IOQM. So these three you should pick first, I think. Right? Recursive series, combinatorics, and your geometry. Okay. These three things are must. Okay. Now minus Tn I'm shifting on this side. So it will become positive Tn, and this side I have 5 plus. This is sum of AP. How many terms are there? N minus 1 terms are there. How many terms are there? N minus 1 terms are there. Correct? Right? N minus 1 terms are there. So sum of n minus 1 terms is equal to n minus 1 divided by 2 into 2a, that means 12, plus n minus 1 minus 1, that means n minus 2 into d. D is equal to 2. D for this AP is equal to 2. That's it. So this is our Tn. Tn is equal to 5 plus n minus 1 divided by 2 multiplied with 12 minus 4, that is 8, plus 2n. So it will be equal to n. So Tn will be equal to nothing but 5 plus n minus 1 multiplied with n plus 4. And yes, this is our formula for nth term. We can check also. Put n is equal to 1. So 5 plus 0 will be equal to 5. Put n equal to 2. 2 minus 1, 1. 2 plus 4, 6. 6 into 1, 6. 6 plus 5, 11. Third term. Put n equal to 3. T3 will be equal to 2 into 7. That means 21 plus, 2 into 14 plus 5, 19. Yeah, correct. And when you put n equal to 3, you'll get 29 also. My geometry is weak. Beta, practice from the books recommended. Okay, practice that. Are we clear? So what are they asking? The sum of first 20 terms of this series. Sum of first 20 terms they are asking. Can we find sum of first 20 terms? By Tn we got, Tn is what? We got Tn is equal to 5 plus n minus 1 into n plus 4. This is our common term, this is our general term. What do we need to find? Sum of 20 terms. So first we'll need to find the sum formula. So we'll have to apply sigma over it from n equal to 1 to n equal to 20. Okay, what is this? Sigma over 5 plus n square plus 4n minus n, that means plus 3n. Okay, minus 4. Sigma over this entire thing we'll have to apply. Okay, from 1 to 20. So this will be sigma over 5 minus 4, 1. So this will be n square plus 3n plus 1 from 1 to 20. Right? Break the sigma. Sigma of n square plus 3 into sigma of n plus sigma over 1. Or sigma over 1 we know already is equal to n, where n is equal to 20. We are finding for 20 terms, so this will be equal to 20. What will be this? N square, n is 20, so 20 into 21 into 2 into 20 plus 1, that means 41 divided by 6, plus 3 multiplied with 20 into 21 divided by 2, plus 20. This is what should be our answer. This is what should be our answer. Let's calculate this. So 2 3s, 10, 7, 10, okay. So 70 into 41, 2870 plus 63 into 10, so 630 plus 20. So 2870 plus 650 is going to give us 3520. Let's check, do we have this option? 3520 is an option. Okay, so this is how you can solve these kind of series also. No need to worry. And these do come in IOQM sometimes. But if you can write the general term, the basic idea which we have learned today is, if you are able to write the general term of any recursive series, you can apply sigma over it to solve the question. Sigma is such an amazing thing. And only 3 formulas of sigma you need to know. You just need to know the rules, and that's fine. Now I'm going to give you a homework question. Today's homework, please note this down. Your homework question is, your Sn is given to you like this: sigma from k equal to 0 to k equal to n, and sigma is applied over this 1 divided by root of k plus 1 plus root over k. Okay, this is your Sn. Then find, what you have to find is, find sigma from n equal to 1 to 99. Okay, on 1 divided by Sn plus Sn minus 1. Okay, this is what you need to find, the value of this. Okay, till 99 it is. Here it is 99. Okay, we'll start from here in the next class. Till then, have fun. Goodbye. Take care. Sorry for the interruptions if we had any. And I'll end the class.